So, I'm not sure I need mic.
You need the mic.
Is better? Okay. So, good morning. My name is Sidi Mohammed Senouci. I'm from University of Bourgogne, Europe. Have you been in Europe before? No? Okay. I hope in the future for you. So, let me first introduce myself. You can call me Sidi. Okay? A brief overview about my career. So, I got a bachelor degree long time ago. I'm not sure in 1995 I was born. How old are you? 20, 25, I think. 22. Oh, like my sons. Okay, so I got a bachelor degree on computer science from Algeria. You know what is Algeria? Where? So I can tell you what is Algeria? In Europe, in US, in Africa, in the north of Africa. Okay? Oh, it's better. Oh, good morning, Vietnam. So as I told you, I got a bachelor degree long time ago on computer science. After I continue, I moved to France, at the University of Sorbonne, which is a university in Paris. So I got a master degree on artificial intelligence. After I continue on a PhD for intensive 3 years of studies on the application of AI, especially machine learning, to mobile networks at Sorbonne University in Paris. After this, I got a position as postdoctoral teaching research fellow at University of Pontoise in France also. After my academia career, I prefer to go to the industry, and I go to Orange. It's an MNO, mobile network operator. Do you know Orange or no? I'm not sure. I didn't see some. Orange, I see it in Japan, but I didn't see it in Vietnam. It's a mobile network operator, worldwide mobile network operator. I was there a research engineer and project manager. I got after that, Taylor professor level at engineering school in Toulouse, INP Toulouse in France. And I was hired as full professor at University of Bourgogne in 2010. And also since 8 years ago, I'm the head of the lab, the research lab at the university, which is where I would occupy. Just an overview is University of Bourgogne. University of Bourgogne is in France. This is the map of France. Okay. And the map of France, we have different, we call them regions. Okay. And I am in this region, which is Bourgogne-Franche-Comté. Okay. And the University of Bourgogne is located in, we have 6 campuses. And these 6 campuses are in different cities. The main headquarters is Dijon, Auxerre, Nevers, Le Creusot, Mâcon, and Chalon-sur-Saône. And personally, I'm in this city, which is Nevers, which is here in the middle of France. In terms of key figures of University of Bourgogne, so the university is too old, older than me. It has more than 300 years old. It was created on 1722. And we have more than 33 students, a lot of international students, okay, and more than 120 nationalities. In terms of staff, I give you the staff. We have different research units because usually in France, when we are a teacher, half of your work is dedicated to teaching and half of your work is dedicated to do research. And doing the research, we do it in laboratory or research units. One of these labs is Drive, what we're talking about. We have nearly 400 diplomas offered at University of Guadeloupe. And between these diplomas, we have an engineering degree that is done in engineering school where I'm teaching, which is PTIT, which is specialized on automotive and transport. So as I told you, the head of the lab, Drive, it's French Department of Research and Information on Vehicles and Components. Oh, I've got a problem there. The screen is blinking. Sorry for that. So, Drive is a research laboratory at the University of Bourgogne. It is located, as I told you before, here in the university and near the Manicourt circuit. Does someone knows the Manicourt circuit? It is a circuit for Formula One. It's closed now, but yeah, a few years ago it was open. No. Okay. So the lab is composed of 60 members, including researchers, teachers, and also PhD students. As I told you before, a PhD student is the fact that one engineer or master student continue for 3 or 4 years in a dedicated topic, and after that he can get his degree. And Drive Lab is working on intelligent systems of energy optimization as well as mechanics and materials and structures. The lab is composed of 4 teams. The first team is dedicated to mobility, energy, environment, and propulsion. Since we are in engineering school, which is specialized on automotive and transport. The other one in is intelligent and connected systems. I will talk about just after. The third one is sustainability and structure. Composite is more related to materials. And the last one is vibration and acoustic for transport. For the since we are here in PTIT, I will focus especially on the team which is sick for intelligent systems and communications. And the research done in this team is these information ICT is information and communication technologies in different domains, ranging from autonomous vehicles, IoT, Internet of Things, and smart grid, the integration of a vehicle to grid. So we did this year, we are working on the optimization of how we collect the data from these different systems. When I'm talking about system, I'm talking about Internet of Things, Internet of Vehicles, etc. How we collect data, how we can exchange data securely, that without respecting privacy, and use secure communication between the different entities. And when we collect them, how we process data in order to offer services for these systems. So we develop solutions ranging from algorithms to protocols. And these algorithms and protocols are using analytical modeling. What I mean by analytical modeling, the system ranging from game theory with the objective optimization and particularly machine learning. And we go from both modeling to simulation and experimentations. So ongoing projects within this team. We have an ongoing project which is 5G Insight. 5G Insight it's an open project between two countries, France and Luxembourg. We have 5 partners, 3 from France and 2 from Luxembourg. And the objectives for this open project is to build security mechanism that goes from attack detection, how to detect attack, and how to mitigate attack. Using machine learning, especially federated learning, I would like to know, first I would like to ask you, what are your knowledge on machine learning? Did you have some lectures on that on machine learning? Are you comfortable with that, or it's totally new for you? Who say I'm comfortable with machine learning? No? If you say no, it's problematic. Because part of my seminar is dedicated to machine learning. Do you know machine learning or no? Do you use ChatGPT or no? Yeah. How ChatGPT works? It's based on machine learning. Okay. So my question: did you have lectures dedicated to machine learning during your life here in PTIT, your studies in PTIT? No? You had machine learning lecture. Okay, what kind of machine learning you are talking about? Supervised, non-supervised? Hmm? Both of them. So you have a knowledge on machine learning. So okay. So within this project, we are talking about using machine learning, especially federated learning, to blockchain, to deception securities, to enhance the security, especially in both in cross-border areas between two countries, between France and Luxembourg, because we can have some security mechanism in one country, and we can have security mechanism in another country, and we have to deal with this cross-border area when a vehicle can move from one country to another. The other project, we have also another project which is an open project. We have within this open project 37 partners, so a lot of partners from different countries in Europe, in Turkey, etc. etc. OPVA means optimization of electrical vehicle autonomy, and the idea within this project, I will talk especially what we are working in our lab, is the optimization of autonomous vehicles. So we are proposing efficient path planning for a vehicle. So if you have your vehicle, your electrical vehicle, and you would like to go from point to another, our solution is to propose an efficient path planning that considers different metrics. So the battery levels, the location of the charging stations, etc., the weather conditions, etc., etc. The other project is Deliver. Deliver means combined land and air freight transport. It's a local project within the Bourgogne-Franche-Comté, and here we have 5 partners. And the idea is Deliver. I will talk tomorrow on by similarly dedicated to the research done within this project. And the idea within this project is to use existing transport, buses, tramway, etc., as a docking station for the drone to the near port of delivery. Okay. rather than using drones for delivery, because if you use drone, there is a problem of battery. Since we have a problem of battery, the idea is to put the drone on the top of the bus, and it's up to the bus to go to the near client, and after directly to deliver to the client. More details for tomorrow. Another project Physiotherapy, really pleased it will guarantee quality of experience of user for a 360 video broadcasting systems. And this is the main topic of my seminar today. Okay. Last project is 6G twinning. 6G twinning, it means integrating network digital twinning. In the future, AI-based 6G networks, 6G network, the next generation of mobile networks. Okay. And within this project, we have 11 European partners. And the idea of this project is to propose methods, simulations, and modeling tools in order to propose a digital twin, a network digital twin, and see if it works. What is a digital twin? Can one tell me what is a digital twin? No? Can someone knows what is a digital twin? Don't be shy. No? Yeah. A digital twin, here we are talking a network digital twin, but the digital twin is something which is, I will say, more large. Okay. We have, for example, it's used especially for industry, for zero, etc., etc. It means what? We have a system, okay, with a real system, okay, and we have a replica of the system which is digital, okay. So we collect data from the system, okay, put it as an input of my model, okay. It's up to model to find, for example, which action I have to do, okay, what is the best action in terms would simulate things, and after that I can act on the real system, okay. So if you have to do optimization, I will not do the optimization directly on the system, vehicle or network, etc., etc. I will only collect data. I will have a replica which is digital, which is a representation of a part of the system, okay. I will optimize it by simulation. If simulation says, okay, this is the good action I have to do, I will send it to the system to do the requested action. Okay, this is so a brief introduction of myself, a brief introduction of the ongoing projects. Let's move now to my seminar, which is dedicated to machine learning based. Oh, let me test. So my seminar is dedicated to machine learning based approaches to ensure quality of experience in 360 video broadcasting system. So you told me that you are comfortable, a little bit comfortable with machine learning. So I'm happy. So my question is, are you comfortable with 360 video? I hope so. Like my kids, they are comfortable with that. So the idea of since you can relate, You have to answer all my questions. I'm joking. Okay. So what I'm talking about is 360 video. If you are not comfortable, I have brief interview of what is 360 video. So usually when we are talking about 360 video, we have a user with a mounted headset, okay? And with this mounted headset, and we have spherical representation of the video, okay? We call it panoramic or omnidirectional. It means I have my headset, I can see my video, and I can move my head in the different direction, 3D direction, X, Y, and Z. And usually for processing, or also to, in terms of processing, and also to show the 3D video in 2D screen, we use the representation, which is ERP, for equirectangular projection. Okay? The 3D video represented in an ERP projections, and when the user is looking to the video, so he's looking some kind, he's not looking at the video, he's looking upon the video, which I will call, which is also called FOV, it means field of view. I'm watching only a part of the video, which is the FOV. Is it clear now what is the FOV? Because it's really important in my presentation. FOV is the part of the video where the user is watching. So when we are talking about the system, the basic architecture is this one. I'm talking about basic because we can also enhance the system. I will talk about it in my conclusion. So we have a user wearing a VR headset. And the other side, we have a server who delivers the video. So we have different images, and we request the video. And after that, the server has sent the received videos to the user. Okay? Why 360 video is important? Could you tell me what kind of applications you can use this kind of systems for what? Rather than gaming or seeing Netflix or something else, do you have a kind of applications of? No? Yeah, Google Art. Yeah, we can also, it's also kind of applications, but the main applications are here. It comes for education. Okay. Virtual tools without leaving the classroom. Okay. For example, for COVID, could be a good solution for that. For the training simulation of professionals. For tourism, for virtual tours, museum or any other destination. Real estate, if we would like to buy, for example, a house, so we can have a real visualization without moving and without going seeing the house we would like to buy. Sport and events, for example, you can attend a match in stadium without going to the stadium. Marketing and advertising. So the application, the logical application of 360 video is large. Okay. And we have two kind of systems. When we are talking about 360 video, we have live streaming. It means that user would like to see a video in real time. Okay, seeing, for example, a match, etc. I would like to see the video in the real time. And we have on-demand streaming. It means that I have the video which is stored in the system, and I would like to watch this video, not in real time, but what I want. Okay? So even if we are in a live streaming or on-demand streaming, we need high bandwidth. Okay? In your opinion, what is the size of single frame extracted on 8K 360 video? Do you have an idea on that? Only one frame. It's only one frame. A frame is about 18 megabits. It's a lot. In terms of networking, we are talking here, we have in PTIT, we are talking about telecommunications. Okay. And sending 360 video or frame, just a frame of it has a size of 80 megabits. It's a lot for all the network. Every network, 5G, 6G, or every network, 80 megabits is a lot. That's why it depends on time we have. I will talk about two solutions that are proposed within this project. And this is a project during the PhD of my PhD, which is Ahmed Sadallah. One of the solution is to reduce the size of the videos that we transmitted. Okay? And the other one is to ensure scalability of this video when we are talking about multicasting. Okay? When we have different users. In the first solution, we are talking about one user who is looking the video and would like to optimize the video that will be transmitted to the single user. And the second solution, if we have time, I will talk about the fact where we have different users watching the same video, how we can enhance the solution of 360 video broadcasting. So, the first one is dedicated, as said just now, is the classification to ensure the quality of experience for users of 360 video broadcasting systems. Classification, what I mean by classification, is some kind of machine learning. Okay, I will explain after what I mean by classification. So, remember, so we have a user with via headset who is watching this video. Okay? And we have, as I told you before, I'm talking here about the basic system where the user and the server. And in the server, we have different kind of images. Okay? We have high quality images and low quality images. You can imagine that we have different level of images. In our solution, we define only two: high quality images and low quality images. So, and the user is looking to the video. Okay. Depending on the quality of the network, I will send it. If the quality of the network is good, I will send it the high quality image. If the network is bad, I will send to the user the low quality image. What is the problem with that? There's an impact of the quality of experience. What I mean by quality of experience is the user, depending on the network, he has a good quality. If the quality is bad, he will receive only bad quality images. It's not good in terms of quality of experience for the clients. Okay? To deal with that, we divide the image in terms of tiles. We use tiling. Okay? Tiling, what I mean by tiling? So, I divide the image in terms of tiles, okay? And I will send to the client in good quality. You remember the field of view? The field of view is the part of the video where the user is watching. So I will send to the user with a good quality the field of view and all the parts of the image of the video. I will send it in low quality. So in terms of quality of experience, the quality of experience is good because the user is always watching a part of video with a high quality. But there is a problem to prepare them. Okay? I have to prepare in the server the images I would like to send to the user. I would like to prepare them. If I would like to prepare them before sending them to the user, especially for real-time video broadcasting, I need to know information about the previous field of view. And based on the previous field of view, it means how the user is moving his head in X and Y. I will predict the future if you read. I will send it to the server. It's up to the server to prepare for me, for the user, the images, the predicted images that will be sent to the user. So as I said, compared to the first solution where I send all the image, here I'm sending only the part of the image, which is the FOV with the high quality, and all the parts, the other part of the image is sent with low quality. The quality, so good FOV quality even if the bandwidth is low. So we need to predict. If I would like to predict, I have to use machine learning. I have to use machine learning. What kind of machine learning I can use? For field of view prediction, because here we are talking about what will be if the user is moving headset like this. For sure, in the next time I will send it this field of view. What kind of machine learning I have to use? What kind of machine learning you know? We have supervised, non-supervised, semi-supervised, reinforcement learning, etc. In supervised, we have two kinds of learning, classification and regression. What is the difference between classification and regression? I have to take a slide on that. Okay. So we would like to predict the next field of view where the user is looking at. So, method that exists, we will use classification, not regression. Classification, what is the difference between classification and regression? Regression, it means that, can I have a pen? difference between, these are the types of machine learning. You have supervised, unsupervised, and reinforcement learning. Okay? Here, today, we will talk only on supervised learning. Tomorrow, I will talk in the other seminar, I will talk about reinforcement learning. Okay? In supervised, we have classification and regulation. Classifications. So I have some inputs, some data inputs. Supervised, it means that I have data with labels. Okay? For example, this is a dog, this is a cat, this is a dog, and this is a cat. I put it as an input of the system. Okay? And when I will ask him if I will ask him, I will give him the system the image, he will tell me if it is a cat or it is a dog. This is classification. So the output of machine learning is discrete, is a class. It's just saying if it is a dog or it is a cat. Classification, it means that the output is a class. Regression, no. The regression, for example, here, the output is a continuous value. So I put as input of the systems the different my data set. It means this one, this house, it will be, for example, I can sell it for this price. This one, it was sold with this price, etc., etc., etc. Okay. When I ask it, the system, I would like to buy a house that has this superficie, for example, please tell me what is the best price. So the system will give me the best price. It's a continuous value, it's not a class. So it is clear now what it means by the difference between classification and regression. Classifications, supervised, it means, First, supervised, it means that supervised learning, I have data sets that are labeled. Okay? This is a cat, this is a dog, this house has this price, this house has this price. So I have the data set that is labeled. Classification, so it means that my system will give me, if I ask him, the output should be the class. Is it a cat or is it a dog? Regression, it gives me a value, continuous value. Okay? If it's clear, let's continue. So we would like to do the prediction of the field of view. And we would like to use classification, supervised learning. Okay? Different methods exist in the literature. We can use neural networks, like LSTM, CNN, you know them, maybe. These methods are very efficient, but they are slow in terms of learning and inference. Okay. There is another method, which is ALIMA, which is usually used in literature, especially for 360 video podcasting. But it's fast. Okay. But it should be trained regularly to better understand the data. If the data change, not sure your system will continue to work correctly. In our case, we propose something simple, which is time series forecasting using classifications. We will see that is fast in terms of inference and also in terms of training compared to the other methods. So, what we are talking about? We are talking about the prediction of FOV. The prediction of FOV. I would like to predict what? Your opinion. The movement of the head of the user. It means what I would like to predict really in two dimensions. I have to predict X and Y. I'm looking to this part, I'm looking to this part. I would like to define to predict X and Y. So, this is what I mean by time series. So, We have a user who is watching a 360 video, which is represented in two dimensions, okay, x and y. And based on this movement, I have to record the movement of the handset on the x-axis and the y-axis. Okay, I have to record them. And after that, I have to use this data set, okay, in order to do my classifications. Okay. To simplify things, because x and y are continuous. You can see that are continuous, so that are moving, x and y are continuous. Okay? We have continuous data. When we have continuous data, it can take time to train machine learning. To simplify things, because what is important? Is it important to know x and y exactly, or to know I'm in this area, this part of the image is interesting? It's not really important to know x and y. That's why we use discretization. What I mean by discretizations, we have data which is continuous values, okay? And based on these continuous values, I will try to discretize in terms of classes. I will not use all this data which is continuous, because when the data is continuous, not all the information is necessary. I would like just to know what is the image, what is the part of the image where the user is looking for. That's why we define this discretization. It means that we would like to know, okay, this is the data set that we would like to use to train my machine learning. So, I have to construct my data set. Okay? We are talking about supervised machine learning. Supervised machine learning, it means that I have the data set which is labeled. Okay? And we are talking about field of view prediction. So I take x and y. Here I give just x, but we have to do it also for y. So I have to set a window. For example, at T1, T2, T3, T4, T5. The user was looking at class 6. Class 6 is part of the image. Okay? And the target is 5. It means that I know that if he is looking 6, 6, 6, 5, 5, I know that in my data set, I know that on T6, he will continue seeing class number 5, which is part of the image. And the same thing, that. So I construct my data set. And I will use the data set to learn, to do my classification. It's clear? Or I have to repeat? No. Not totally. Not totally. I have to repeat? I have to repeat, okay. Is this part clear? This part is clear. I have x and y which is continuous. I have to discretize because it's not really important to have the real values of x and y. I have just to know what is the class. Okay. After that, I told you that I know, for example, I know that the user, for example, here, I take this one. When he was looking to this class, after he moves 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 to this class. This class, for example, 6, 6, 6. No, it's not the 5, 3, 4, 5, 6. 1, 2, 3, 4, 5. After at t plus x plus 1, it will continue to see the same class. Okay? This is what I put here. Just I construct how the classes change over time. If the user is looking to class 6, 6, 6, and after move to 5, 5, okay, my data set says that he will continue to see 5. My data set says also if he looks 6, 6, 5, 5, 5, he will continue to see 5. My data set, okay, it is the same. It's just a representation of this as a data set. I'm just constructing my data set. If he is looking 3, 3, 3, 3, he will continue to see 2 and 2. Okay? So I continue to construct my data set by ranging all the x and y. Yeah.
So what's the feature of the input data? I still don't understand that the input of the model is the size of the field of view.
Not the size.
Size window here is.
Not the size of the window. The input of the data set it's x and y. My head. I'm looking, for example, to see it's x and y. And when I move it to this, it means that x is moving. When I go to the up, y is moving. How my head is moving in terms of x and y. These are the inputs of my machine learning. How the head is moving in terms of x and y. These are the inputs of my machine learning.
So the instant moving of head view is the input of data set.
Yeah. So these are the inputs. Yeah. And while my head is moving, it's also I'm changing my field of view. When I change my head, it means that my field of view is also moving. Okay. So I construct my dataset for x, and after I do the same thing for y. So I have my dataset for the movement of x and the movement of y, how the user is moving when he is watching a certain video. Clear? My dataset is constructed. When I have a dataset which is constructed and which is labeled, what I mean by labeled, it means that I know what happened in the past, and I know what will be the target. This is the level. Okay? So we can use machine learning. And here, do we have to use classification or regression? What is the output? Is discrete or continuous? Discrete is class. If it's discrete, so we have to use classification. Okay. What kind of algorithm you know could be used to do classification in machine learning? It is cat, it is dog, it is that, etc. What did you see during your studies? No? No, the algorithm you're using of the algorithm that if you would like to do classification, what kinds of algorithms you can use for classification? Huh? Close.
I consider mistake regression as a most of my
No, he is supervised. Not supervised. I'm not talking about supervised. If you are talking about unsupervised, you are talking about clustering. Not talking about clustering. No difference between supervised and unsupervised. Huh? Yeah. Karen. Yeah. Good. Thank you. There is Karen that can be used. prefer to use naive bias. Do you know naive bias? Naive bias, it's classification algorithm that is based on probabilities. It's really simple, that's why we prefer to use naive bias. It's computationally efficient. Why it is computationally efficient? Because it is based on the calculation of probabilities. That's all. And we use it to predict the FOD. So, how naive Bayes works? Naive Bayes, just for those who did not remember how naive Bayes works, naive Bayes is based on Bayes theorem. Bayes theorem. Used to calculate the probability of a given class. For example, to say if this email is a spam or not spam, this photo is a cat or a dog, etc. Based on the observation of certain characteristics, the features. Okay, for example, the number of words in the emails, and is expressed with the formula which is here. Okay. Why it is naive? Why we say naive? Because naive bias consider that all the features are independent. And when the features are independent, if the probability of x and y, if x and y are independent, is equal to what? An operation of x and y. If x and y are independent, if x and y are independent, are two variables that are independent, the probability of x and an operation of y is equal to what? Probability by x multiplied by the probability of y, if they are independent. Okay. If it's not clear for you, maybe I have to explain it. I prefer to explain things up. I will move. Suppose that we have, for example, just a reminder about your this is really important. Only some of you are comfortable with that. I prefer to talk about also naive bias, just a reminder. So, how it works naive bias? I told you that naive bias consider all the features, because when we are talking about machine learning, you have some inputs, and these inputs are characterized by features. Suppose that we have to I have a system that I have to learn things, and the features are blood pressure, cholesterol level, body mass, family history, and heart disease. And I would like to, for example, to predict something for the person in terms of health. Do you think that I can use naive bias to do it? No. Are these variables independent or no? They are dependent. The fact that the body mass is also linked to the cholesterol. I know that. In terms of mass, I have to put it through. It's related. When the variable, when the features are correlated in your system, in your machine learning, when the features are correlated, so I link it to each other, you cannot use naive Bayes. Okay? In our case, x and y are correlated or no? They are not correlated. I can move that like this. They are not really correlated. The movement of the head in terms of x and y are not correlated. That's why we can use naive Bayes. Okay, I give you here an example of naive Bayes. Suppose that we want to calculate the probability that the car has an engine problem, given that it makes a strange noise. Okay? A, the probability that the car has an engine problem is equal to 10%. Okay? And B, the probability that the car makes a strange noise is, suppose that this is equal to 5%. Okay? And probability of P, knowing A, probability that a car will make a strange noise if it has an engine problem, it is equal to 80%. Naive Bayes says the probability of A knowing B, the probability of A knowing B is the probability that the car has an engine problem if it has a noise, if there is a noise. If we calculate this, it's equal to 160%. That's why it's really important nowadays. Okay. How it works nowadays, I give, for example, here a data set. This is what I use in my lectures to remind naive Bayes. Suppose that we have 10 objects, okay, and they have different features. The color, which is red and yellow, the shape, round or cylinder, and the diameter, which is higher than 10 centimeter and less than 10 centimeter. And we have our data set that says if object 1 is an apple, 2 is not an apple, etc., etc. Okay? And the output is, we are talking about classification. Just now, if the object is an apple or is not an apple. Okay? So my question is, if you have this object, which is red, round, and the diameter is higher than 10 centimeters, is this object an apple or not an apple? LLO higher than 10 centimeters, it's not an apple. So what do you have to say? It's an apple or it's not an apple? We have to calculate the probabilities. This is the step 1 is calculating the conditional probabilities, and after we have to calculate the probability that C1 that it is an apple, and the probability that is not an apple, knowing these attributes. Okay? I will not go in depth on that. Okay? But I will calculate the probability of each class. Probability that it is an apple, knowing the exact attributes, is equal to that. The probability that it's not an apple, it is equal to that. What is the higher value? This one. So what we can say, x is an apple. Okay. So as the model works by the calculating of the probability of each region, as we said, okay, for x and y. And after, we have, if we have a new data to be classified, I have to calculate for each class, not except y, because we have different classes in our system. We have to choose the class with the highest probability. Okay? To do that, so if you are talking about machine learning, we need data sets. Okay? We prefer to use in our work existing data sets. We use this data set where we have 48 volunteers watching 18 different videos. Okay? And all the videos in our case, we divide it in 12 by 10 tiles. Okay. So in terms of results, we compare our solution, which is here, to ARIMA. I talked first about ARIMA. And we also compare to neural network solutions. And we can see, in terms of inference, what I mean by inference, what is the inference of machine learning? It means when I ask the system, the model, saying, okay, please give me if I'm class 1 or class 2 or class 3, this is the inference. I give him the input and the system should give me the answer. So here we can see that our solution, which is based on slide base, is really better than the others in terms of inference, in terms of milliseconds. It's about 5 milliseconds. ARIMA is about 200 milliseconds. It's a lot. Okay. And LSTM, CNN, and CNN and LSTM have higher inference time. In terms of precision, I would say. We calculate the cumulative distribution function. What is the CDF? CDF is cumulative distribution function of correct prediction with an error distance of the different algorithms. I will explain. So we are here comparing our algorithm, which is in blue, with the other one. One, the error distance is equal to 0. What it means 0? It means that if the user, for example, is looking this part, this time, and the prediction say me that how the user will see this part, this time, this means that it was correct. The prediction was correct. It means the distance between the prediction and the real value is 0. Because I'm predicting the right one. Okay. When the prediction, for example, the error is equal to 1. What it means equal to 1? It means that the system predicts me that the user is looking this part of the video, but really he is looking this part of the video, this time. So the distance between the two tiles is equal to 1. This is equal to 2, it means that the user is looking to this part of the video and the system predicts 1, 2, predict this one. Okay? So we can see that the probability of x equal less than 1, because it is really important, this part, 0 and 1, these are the most important ones because I'm looking the same, the prediction is correct, or the prediction is not far from the reality. So the prediction that x is less than 1, so it is equal to 0 or 1, is about 95%, which is correct. Okay? So we compare our solution in terms of inference, in terms of precision to classify, and the last part is in terms of training. In terms of training, we can see that our algorithms The training, what I mean by training, it means that I have my model and I will enter the data set and let him learn. Okay? Our algorithm takes 2 seconds. Okay. The other algorithms, Chuyên and etc., they take a lot of minutes. Okay? So in terms of inference, it is good. In terms of precision, it is good. And in terms of training, it is the best. The second part of our lecture is dynamic filter view-based clustering for efficient 360 video multicast streaming. I will explain. A reminder what we said at the beginning. So we have, this is what we talk about first. We have a user with a mounted headset. He is looking to the video. We are predicting the field of view. The system prepares the image and sends them to the user. Okay? Suppose that we have different users. Suppose that we have different users looking to the same video. What happens? Usually, we predict, the system prepares the video, and send them in a unicast transmission. What I mean by unicast, you know what is the difference between unicast and broadcast? Yeah? I hope so. In PTIT, unicast transmission, it means that point to point. Broadcast is one to all. Broadcast is one to all. It's what I'm doing here. I'm talking to all of you. I'm broadcasting. Okay? And multicast is one to a group, one to many. Okay? Just a group. Broadcast is one to all. Multicast is one to many. Just a group. Okay? Here, when we are talking about unicast transmissions, suppose that we have a lot of users. Do you think that the network will support that? More the users are, more unicast transmission we have to handle, the system can handle. In terms of performance of the network, it's not good. That's why there exists the multicast solution. Multicast solution, it means that they have to create groups. Okay. The groups of users that are looking to the same part of the video, I have to put them in the same group. Okay. And I will send you multicast transmission. I will not send unicast to everyone, but I will create the group. I will send the videos to the groups that are watching the same part of the video. So when we talk about grouping users, we would like to group users. What kind of machine learning we can use? K-means we have to use non-supervised learning. Non-supervised learning, it means that supervised, what is just a reminder, supervised, it means that I have data which is labeled. Non-supervised, that I have data, and I have to group them based on their attributes. If they have the same attribute, I have to put them in the same group. One of the main algorithms that you know is Cameron's. Okay? So, there are different algorithms, Cameron's, we talk about. But what is the problem of Cameron's? You know how Cummins works? He knows. Not the others. You know how Cummins works? Who knows that how Cummins works? Otherwise, I have to remind. Who doesn't know? Either you know, either you don't know. So, who knows how Cummins works? It's just to know if I have to remind or not. You know. A little bit. Okay. Let's remind it. So, uh, uh, let's remind how unsupervised learning, especially clustering. Clustering is part of unsupervised learning. It means the data is not labeled, and I have to group this data based on similarities. I give you an example: group all customers in 10 groups based on their buying habits, etc. So, okay. If we would like to group these shapes according to the similarities, how many groups you will have? 3. I can group them in terms of size, number of branches of each shape, etc. It gives me 3 groups. Okay. One of the solutions is Camill's clustering. How Camill's clustering works? It's an iterative algorithm in which we ask the machine to find the number of K clusters. It means that I have to identify K. Okay. I have my data, randomly place K points in the space, then move this space to so that they are become the barycenter of the cluster. For example, if we take K equal to 3, it means I would like to create 3 clusters. Okay. Here, if in terms of visualization, just like that, I can see how many clusters? 3 clusters. You mean? Without just by visualization of the data, you can see that there are 3 clusters. 1, 2, 3. But the machine doesn't know. Okay? But just by visualization by ourselves, we can see. Okay? Within machine learning, visualization is also good in order to identify the K, for example. Suppose that we have K equal to 3. So I put the 3 points randomly in the system. After that, so I put them here, and after that I will associate each point in our data set with the central unit to which it is closest. So I have this central unit, this one, I have 3, okay? I will associate all the points in my data set to the nearest central unit. So this one goes to there, this one is related to this one, and this one's points are connected to this central unit. with k equals to 3. After that, I have to move the centroid to the center of the group. This is the group, the first group. This centroid I put it in the middle, here. Here. This is the group, the blue. This centroid I put it on the middle of the data. And here, this is the group. The centroid I put it on the middle. Okay? Tap, tap, and tap. Okay? As the position of the centroids has changed, the centroids now have different nearest neighbors. So I have to repeat the algorithm. I have to calculate, I have to link all rays in each point to its nearest centroid. So this one will be connected to this one will be connected to this one, and this one will be connected to this one. I repeat the algorithm till the centroids will not move. If the centroids will not move, it means I can have my cluster. This one, and this one, and this one. So if I would like to do clustering, to do groups, k-means is the solution. But k-means I have to define k. Based on the user that are watching the videos, do I know how many groups? No, I don't know. So k-means works if I know display definite number of groups I would like to form. Okay? There is some other clustering algorithm, hierarchical clustering, efficient but very complex. DB-scan, which is density-based clustering, less complex. But it detects clusters of arbitrary shapes. We will compare it to our algorithm, we will see that it is also the case. So our approach usually when we propose things, and in the future, if you have to propose things, you have to propose simple things. More simple is the solution, efficient is the solution. For example, for the first proposal, you propose to use like layers because it is simple. Okay. Here we propose another approach of clustering, which is also simple. Because if the problems with the problem we can resolve it with the simple solution, try to use the simple solution. We will not use neural network. We will not use a bazooka to kill a fly. You agree with me? To kill a fly? It's enough. Okay. So how our algorithms work? So I have to sort the users. These are the users, user 1, user 3, user 4. I have to sort them from the left to the right. And I define a distance between two users. Users, I'm talking about the field of view of the users. It is equal to that, the distance between the centroid of each, the centroid of each field of view. Okay. I set the threshold. In our case, I set this threshold equal to 2. And the window W is equal 1 second. It means how the user moves his head in 1 second. Start with the user whose left neighbor is farther than t. For example, here we would like user 2. And we calculate the distance. The distance, which is when we calculate it, is equal to 4.5. It is higher than the threshold. Okay? If it is higher than the threshold, So this user and this user will not be in the same group. Okay. After, I will calculate between this user and this user. If I calculate it, the distance is equal to 1. If it is equal to 1, it's less than the threshold. So this one and this one will form the same group. The same thing, this one and this one, the distance is equal to 8. They are not in the same group. And the last one, I will calculate the distance with this one and the other one, because we are talking about spherical representation. It means that the end of this part is the beginning of the part, okay? Because we are talking about equirectangular projections. So if we calculate the distance, it is equal to 0.5, it's less than the threshold, so we form here two groups. These are the two groups. So here we define it with the threshold is equal to 2, but this value is really important. For example, if we take, for example, the threshold is equal to 2 within this image, we can have, for example, 4 clusters. If the threshold is equal to 4, we have 3 clusters. If the threshold is equal to 6, we have only 2 clusters. So it depends how to choose this threshold. It's really important in terms of performance. So we try to analyze the performance of a solution. So in terms of complexity, uh, the hierarchical clustering is about n power 3. When the complexity of n power 3, it means that the system is very complex. If, for example, if you have 1,000 users, we have 1 billion operations. For Davis scan is not too complex. Well, the problem is log n or n log n, it means the system is not complex. It is clear for you what I mean complexity of the algorithm or no? When the system is O n or O log n, no? Say no if no. In terms of complexity, let me remember my if you have, for example, a table, okay? Okay, and this table is, for example, of size of 1, 2, 3, 4, 5, and here is equal to 6. If I would like to tell you, find me the smallest value. What is the smallest value? Is 0. What is the complexity of your algorithm? I have to go from the beginning of the table to the end of the table. Okay? If the table is how many operations I will do, I take this one, I compare it to this one, to the second one, I compare it also to the second one, to this one. How many comparisons I will do? And yeah. So the complexity of this algorithm is log n. Okay? It means how many operations you have to do. This is what I mean by complexity. If we have to do, for example, if I would like to multiply two matrices, if I have to multiply two matrices, what is the complexity of this the algorithm? N power 2. Log n power 2. Okay? This is what I mean by complexity. Okay, how many operations are needed to execute the algorithm of the program? So we can see that, yeah, our algorithm and density and data scan are less complex compared to hierarchical algorithms. So the same thing, in order to compare our solution, we evaluated through the same data set, which is composed of 48 users watching 18 videos, and we compare it in terms of Davis-Boolean index. What it means, Davis-Boolean index, when we are talking about clustering, it means that I have to group the users. Okay? So Davis-Booleans measure how clusters are separated and how compact they are. Okay? If we have, for example, if we have cluster here, and cluster here, so the clusters are far from each other. Yeah? And here they are compact. For example, if here we have only one user that belongs to this group, it's not totally compact. This one is compact, this one is compact. Suppose that this one is compact, this is good. The double scan will be good. Okay. If, for example, we have a group here and we have a group here, the distance between these two groups is less. It means that the Davis-Boolean will not be good. So, when we can see when the Davis-Boolean is less, is small, it means good performance. So we can see, for example, here, Davis scan to our approach. We can see that in terms of different size of frames, we can see that our algorithm is better than Davis compared to Davis scan. We can here give an example of clusters. We can see that our clusters are regular. In terms of Davis scan, the clusters are irregular. We have also another example. For example, here we can see that our algorithm creates 4 clusters. Davis can create only one cluster. So what we see today, we propose a solution for 360 videos. So we propose one solution that reduces the size of the video to be transmitted. I will not send all the video, but I will send only the filter view, okay, in high quality. The other part of the video will be sent with low quality. So I will predict what the user will see and send him the requested video for only one user. After, we propose a solution to ensure scalability. It means when we have a lot of users watching the video, the network will not be will suffer. If it suffers, we have to propose solution by creating groups and sending the information not unicast, but a multicast solution. One of the solutions I didn't talk about is using caching. It's because in the basic system we propose a user who is watching and the connection is directly to the cloud, to the server. Okay. One of the solutions is the reduced number of requests to the server using an edge nodes, which could be a base station or anything else. Okay. And to put in the cache, for example, the most important parts of the data are requested by a lot of users. I don't know what you would like to do after your studies, but if you are interested to continue on the PhD, we are hiring. If you are interested by this topic, we have a joint PhD dedicated to optimization of spatial video streaming for immersive operation autonomous robots. This PhD will be the first part, 18 months, 1 year and a half in France. And after the PhD will continue in Japan, in Tsukuba, within the lab between IST and CNRS in France. So if you are interested to continue a PhD on next September, October, please apply as soon as possible because the selection is done now. That's all from my side. Thank you very much. Have any question?